Hey there, and welcome to another episode of me looking at websites from quantum technology companies, including quantum computing, communication, and sensing. Today we are looking at Rigetti. Rigetti is one of the known quantum computing brands, so I'd be lying if I would pretend now to not know what they are doing. So they're working on quantum computers. You can see here our 9-qubit QPU is ready to ship today. So that's already a statement. And with that, let's actually dive into it. Let's take a look at what their website is saying, what the technology is that is behind it, and how everything works. And let's just check it out together. So it says, think quantum. And then we see this very stylish image here with the turquoise background and the black let's say outlines of the inner workings of a quantum computer. So you see the chandelier again, which is the inside of a cryostat. Let's scroll down. Ooh, that's a cool animation. And then it becomes colorful. And now, oh, that's even almost an educative experience now. Let's see what these things are doing. Okay, dilution refrigerator. So, I can almost do an online course with this now. So this is a description of the inner workings. Then we have the signal chain, the different temperature stages, the mixing chamber, which is basically the heart of this dilution refrigerator from a refrigeration side of things. And then, there's the QPU, the quantum processing unit. Okay, nice. So now we learned something about how the cryostat is set up, or the computer is set up. What else do we have here? So the Novera QPU is a 9-qubit QPU, which gives you unprecedented access to quantum technology and empowers you to take your research to next level. So this is really focusing towards research institutions. First of all, it's ready to ship today. So that's like one of the, let's say, selling propositions they put out here. If you order it, you get it right away. And I do get, they are one of the, let's say, most established companies. They've been around for a while. And then, of course, with such a statement, they also show it, right? They say, okay, you can talk with all of the other startups, and then you put yourself into an order list. You don't even know if they have something up and operational, but if you order with us today, we can ship it to you right away. That's a pretty strong statement. Then here it says something Rigetti right now. So that's probably, you see the T1 and the T2 lifetime, single qubit gates, 2-qubit gates, like the fidelity values. So this is like the let's say the benchmarking of their qubits, and probably it's interesting at some point to do like a video which is an overview of all of these benchmarking numbers of the different companies. If you want to see that, let me know in the comments down below, and I'm happy to do that. Might also become a little bit dry, right, if I just go through all of the tables, but maybe I can explain also a little bit what are my thoughts on this. Don't know. Then you have technology partners here. You see big brands like NASA. Then also brands from the quantum universe like Q-Control. You have Oxford Instruments, which is also, for example, very well known in the cryostat manufacturing and generally like scientific instrumentation manufacturing. Then you have distribution channels. Here it's starting to get interesting. You see like AWS and Microsoft, which are cloud providers. So I assume that via those clouds you might also get access to a Rigetti machine. So that's definitely interesting. And then down here we see the latest in quantum thinking, which is probably the news, or maybe that's even more like the research side of things. You see like system R&D, algorithms and applications. So this is like news articles from the scientific side of things, I would guess. And then we see here, keep exploring. And with that, let's quickly go up again. So, that's interesting. So we have the why, how, what approach, but not the how. We just see why and what. So why is probably like the sales pitch about why you should buy a Rigetti system. Create new opportunities with tomorrow's most advanced quantum computing technology. So new computing paradigm, find your quantum advantage. Okay, that's cool. Then we see the industries again and use cases. So let's see if we have the usual suspects again. So design and optimize new molecules, check. So this is pharma, drug discovery, like the typical pharma thing, check. Then we have develop synthetic enzymes and catalysts. So this is material development, check. Then we have optimize returns and risk for portfolio. So that's the financial industry as well, check. Then we have something which I guess goes into the direction of logistics, which is, that's down here, reduce fuel costs by optimizing vehicle routing. And then we also have something AI related. I was a bit confused because I thought first it was logistics, but here you see like probably a self-driving car. So train better AI with less computational overhead is very much focusing on the training part rather than the execution of the AI. Then what do we have here running on Rigetti? So you can see Amazon Bracket, which is the quantum service or like the quantum unit. You can also see here run on Rigetti quantum systems through Amazon Bracket of AWS. And AWS is, for all of you who don't know, which is probably no one, a provider for servers, for large compute infrastructure around the globe, one of the biggest. Then we have Microsoft Azure or Azure, depends on whom you ask. I have heard different versions of how it is being pronounced. There's Azure Quantum, which is the, let's say, quantum branch of the of the Microsoft Cloud. Sorry, it's Microsoft. Here you see take advantage of $500 and free credit for Rigetti. That's cool. And you can even apply for a $10,000 grant. That's also very cool. So do your research with a Rigetti machine in the cloud. And then we have here StrangerWorks QC. StrangerWorks QC run on Rigetti quantum systems through StrangerWorks QC, a completely free collaborative development environment, or StrangerWorks EQ, an enterprise-grade quantum service provider offering everything you need to kick off and manage your enterprise quantum efforts with granular security, IP protection, quantum machine access, resource aggregation, custom integrations, private development, deployments, team and project management, dedicated support, online training, and more. So that's another way of basically running it, I guess, in the cloud. Very cool. Then you have some more applications running on Rigetti. So you see this site is really full of applications, people that are using those machines in some context, may it be for research, may it be in operation, I don't know. We will figure out more about this probably if we click on view more. Oh, that's a long list. Okay. I will not go through all of this. If you want to check it out, then for sure go to their website and check it out. Link to the website will be down below in the video description. And yeah, that's a lot of applications probably that are running already. Let's click on the next one, which is what? Scalable quantum systems built from the chip up to power practical applications. So again, they basically start with the fabrication, with the design of the chip itself, so the real quantum hardware, and then probably from there on it goes up. So it says building quantum computers combines advances in engineering, physics, computer science, and manufacturing, integrating all these specialities under one roof and in one technology stack allows us to move further faster. So again, they say they start with the very fabrication of those chips, so basically clean room work, which is also what I see here, like MEMS processing technologies, like manufacturing facilities. So this is very much like from the ground up. And then probably also here it goes all the way to like software. Then we see here the superconducting quantum processors. So this is very much at the heart of this whole thing. You have superconducting qubits. So again, like Josephson junctions, things like a transmon qubit that are being used in order to store and process quantum information. You see again like the word NISQ popping up here. So these are not yet error-corrected qubits. They are qubits that have some errors to them and that accumulate over time. The better your fidelities and so on are, the less of these you will collect, but still they will be there. They will not be completely mitigated. Then it says nonlinear Josephson inductance here, which is probably the part that is important for this qubit. So if you just have a normal, let's say, superconducting system without any junction or anything, then you cannot really build a qubit that ties down to the Loss and DiVincenzo criteria. I will definitely make at some point a video also explaining this, but basically you need a unique system, like a unique level system which is identified as 1 and 0 for your qubit, and for that you need this non-linear element in your system. In this case it's Josephson inductance. Operation range is 3 to 6 gigahertz, which is basically correlated to the energy range that you have in this two-level system. So they will mostly operate in the gigahertz range. And then what else do we have here? We see control systems. So this is usually the electronic systems like amplifiers, signal generators, and so on, but also the processing of those signals that come back from the cryostat. So you see here an FPGA, so field programmable gate array based control, which is a very high performance and quick acting control, but you also see cryogenic dilution refrigerators. So they really build a lot of stuff, basically everything that goes on the hardware side on themselves, specifically for their applications, as it seems. You see that there's like 10 coax lines with high signal density, so they also have like the radio frequency components explained in here. That's actually a pretty informative text, I would say. Then you have the QCS platform, which is the Quantum Cloud Services platform, which basically, I assume, hooks up your quantum computer to the cloud. You have the operating system and the APIs, so basically the interfaces that you can use to call your quantum computer. And wow, there's a lot of stuff in here already. It's like user authentication, probably you have some tokens, like typically for these API things. You have scheduling, so probably like if you have multiple jobs in there, it's automatically being scheduled, memory management, and so on. So there's a whole infrastructure already here of software. You have kill, I guess it's pronounced kill, but let me know down in the comments below if I'm saying something wrong here, which seems to be the assembly language. So basically the language that the quantum computer speaks at the lower level. So the one that is controlling the electronics that are getting the qubit to do specific interaction. And then you have kill T, which is an extension, okay. Gate definitions, pulse parameters, programmable, okay. So basically that extends on top, and that's also available in Python, I guess, because there's PyKill. Then you have the software tools on top. There again you see PyKill, which is the Python software platform environment, quantum virtual machine, QVM for simulations, the Rigetti quantum simulator. So oftentimes it doesn't make sense to do every iteration on the real quantum system right away, right? So in order to save some of this preliminary work and to make sure that you have a, let's say, better utilization of the runtime, it oftentimes makes sense to do some of these let's say, preliminary works on your own system and simulate those. As long as the number of qubits is small enough, you can easily do those simulations. As soon as you start to scale up, things become, of course, more compute intense in the simulation. Okay, so I will skim over that in order to not make it too long. And then, okay, here we see now again some of these benchmarking numbers, and I assume that these are all the different architectures. Yes, so if I click on them, I can see all of the different iterations here. It also shows the year at which this chip was deployed. So here we see 2017, and here we see 2024. So lots of things that have changed. So from 8 qubits to 84, and then 99.9 single qubit gates fidelity from 96. So quite a big improvement. Definitely also something to look into at some point and discuss those numbers. Okay, what else do we see here? We see here it says Blue Force, which is a cryogenic supplier. Just wanted to quickly mention this because it somehow jumped into my eyes. And it says, yeah, they provide cloud providers, public cloud providers, HPC, private cloud operators, as we saw before with AWS, for example, professional services and application providers. So all the different areas that they are providing to. Okay, get your hands on Quantum. So here you can order it right away. And then, yeah, there's some video where you can learn a little bit more, I guess, about what the current version of the chip, of the 9-qubit QPU looks like. What else do we see here? Some more numbers and statements. Then again, you see the benchmarking results. And here you can see some numbers. So here it says from 900,000 USD, you can basically order one. Okay, very cool. I actually really like those animations here. They're quite helpful to also understand what we always see at these pictures from the quantum machine. So definitely, if you want to learn more about that, then check out this website. I think this is really helpful and explanatory. Then you also see something here about the chip layout. You see tunable transmons, so superconducting transmon qubits. And I guess here we see those 9 qubits, and then we see the couplers in between the qubits. So they are set up in a 3x3 array. And then, yeah, you can basically couple always 2 of those qubits, which is, I think, standard way of approaching this. We had seen in another video earlier in this video series also something that looked more like a star shape, which I think is not so common yet. There's also a 5-qubit chip, and then we have some more things like how to operate. So there's a lot of information actually here. There we see Blue Force again as a cryogenics partner, but also Oxford and Maybell. And then we have control systems. So like, for example, Zurich Instruments, Q-Blocks, and quantum machines. I think I should also at some point do a video on those here. Then we have the software providers. I will not read through all of this now. The integration service providers and the QEC solutions. So just to point out, this is basically like building a classic computer. You have a lot of different components that come together. Rigetti is basically bringing all of these together into the system, but it requires a lot of expertise, and all of these suppliers or partners, whatever you want to call them, they supply with a specific expertise in their specific area. Yeah, and I guess it makes sense to also look into those into detail in a future video. Let's quickly take a look at the About page. Here we see We are on a mission to build the world's most powerful computers to help solve humanity's most important and pressing problems. So again, we see the mission statement, which is targeted towards humanity and solving humanity's problems. We see something here about the approach. Rigetti Computing is an integrated systems company. We build quantum computers and the superconducting quantum processors that power them. Through our quantum cloud services QCS platform, our machine can be integrated into a public, private, or hybrid cloud. Here we see the people behind Rigetti. And I mean, there's many, many more. This is just a let's say, short overview. And we have the news portal here, which, yeah, the last one is about closing an investment. Okay, very cool, very cool. I think with that, I would already like to close this overview. If there are some further questions on Rigetti, please let me know in the comments down below. As always, please make sure to stay hydrated. If you like the channel, then please subscribe to don't miss out on any future videos. And with that, I'd say cheers and see you in the next one. Bye.